Both are good.
Yep, I started it.
Okay. The combined weight of two airline passengers' checked luggage is 105 kilograms. The airline's checked luggage policy allows each passenger a maximum weight at no charge and charges a constant per kilogram weight rate for any extra weight. One passenger pays $12 for the total extra weight of their luggage, and the other passenger pays $18 for the total extra weight of his luggage. If all of the luggage had belonged to one of the passengers, the overweight charge would have been $78. How many kilograms of luggage is one person permitted without charge by the airline? Okay, so basically what's happening here is we have two people, they're checking their luggage into an airport thing, and the airline has like a base weight where they don't charge anything, but after that, any extra weight that you have, they're going to charge a per kilogram rate. And then we have like a bunch of stuff talking about it. So what we could start with doing is we can say x x and y um, are the weights of each of the people's luggage weights. So x will be for the $12 passenger, and y will be for the $18 passenger. So these are the luggage weight of passengers. Okay, so first we have that the combined weight of the two airline passengers checked luggage is 105 kilograms. So that's just saying x plus y is equal to 105. And then it talks about some how much each passenger paid for the extra weight. So what we can do is we can say z is the amount of baseline weight that the airline allows for you to carry for luggage until they start charging a per kilogram rate for your extra luggage. So we'll say that z is weight weight of luggage no charge. And then we can also say that R is going to be the rate of charge of extra luggage. So then when it says that one passenger pays $12 for the total extra weight of her luggage, so we said that X was that passenger's total luggage weight. And then so Z is the amount of weight that the airline lets in without any extra charge. So then the extra weight that um, the extra weight of the luggage that the passenger has will be X minus Z. So then we're going to multiply that by R to get the cost that she'll have to pay for the extra luggage. So that will be equal to $12. And then same thing for the other passenger, except this time it's Y and with 18. And then it says if all the luggage had belonged to one of the passengers, the overweight charge would have been $78. How many? And then it asks the question. So if all the luggage had belonged to one of the passengers, then we're only going to subtract one time of Z, right? So then that person is going to have a lot more extra luggage weight than if the two passengers were just separate, right? So if one person had all the luggage weight, then their total luggage weight would be X plus Y, and then their extra weight would be X plus Y minus Z, and then we multiply that by our rate to get how much they paid, and they paid 78. So then we see that we have four equations and four variables. Then we can solve for that. And you are allowed to have a calculator on target. So we can just plug it into our calculator, which I'll do right now. Um, Um, Bill.
Yep.
I plugged in the equations in the cast, but oh, never mind. Mine did work. I was
Okay.
using linear solver. Okay.
Okay.
So then I get that, so it's asking for how many kilograms of luggage is one person permitted without charge by the airline, so that's C, and Z I got is 40, and yeah, that's the answer. So the answer is 40. Anything you want to say for that question? Oh,
Uh, I mean, any other way to do this problem would just kind of be like a variation on just doing the algebra. So, yeah. Okay.
yeah.
Next question.
Okay.
I mean, you can do it other ways too, like, but in the end, if you do it
In
other way, it's
yeah,
just
in
kind
the
of
end, it's
yeah. In the end, you're doing the same thing as doing the algebra.
yeah. Okay, next question. Number 7, the product of all the positive factors of 6 cubed can be written in the form 6 to the m for some positive integer m. What is the value of m? Okay, so for this one, what you can do is you can first find the number of total factors that 6 cubed will have, right? So you can first prime factorize 6 cubed, so 6 cubed is going to be equal to 2 cubed times 3 cubed. And then the number of factors that, the total number of factors that 6 cubed will have will just be, 3 plus 1 times 3 plus 1. The 3's come from the exponents of 2 and 3. And then this is equal to 16. And then, so whenever you think about, whenever you're like creating a factor for 6 cubed, I suppose, what you're doing is like you're choosing what exponents you want, what you're choosing what exponents you have on the 2 and 3, right? And the exponents can range from 0 to 3, and they're integers, right? And the same thing for 3. Um, and then, whenever you choose these factors, there's not going to be like a preference for any of them. So like all of them are going to be evenly distributed in whenever you like they're just all going to be evenly distributed with all of the factors, right? You can essentially see it as like a table where you have like so like this is your exponent of 2, and then this is your exponent of 3, and then it's just 0 1 2 3 0 1 2 3, and it's just a table like this, right? And then from here you can also see that there are going to be 16 factors, so basically they're all like evenly distributed. So whenever you're multiplying this all together, it's like you're adding all of the exponents together of the 2 and 3, right? So then what you can do is you can look for what the average of all of these numbers are. So like what the average exponent of your 2 will be. So in this case, your average exponent is going to be 6 over 4, which is equal to 3 halves, and the same thing for 3. So your average exponent for 2 is 3 halves, right? And you're going to have 16 factors. So if you're adding all those exponents together, then the sum of your exponents of 2 is going to be 16 times 3 halves, which is equal to 8 times 3, which is equal to 24. And same thing for 3, since it has the same average exponent. So then that means with all the factors of 6 cubed, and if you add all of the 2 and 3 exponents, you're going to have a final exponent of 24 for 2 and 3. So that means if you multiply all those factors together, you're going to have 2 to the 24 and 3 to the 24. And then the question asks for that the product of all the factors be written in the form 6 to the m for some positive integer m. And we can just put this back into 6 because we have the same number of the same exponents on the 2 and 3. So you can just put this into 6 to the 24. So then m is equal to 24. And that is the correct answer. So our answer is 24. Anything you want to say for that one, Bill?
Oh, not really. I think you went over everything. Um, okay.
Okay. Okay. Next question, number 8. 7 identical red cards and 3 identical black cards are laid in a row on a table. How many different arrangements are possible if no 2 black cards are allowed to be adjacent to each other? Do you want to do this one, Bill?
Yeah, sure. Okay, so semi-identical red cards and 3 identical black cards are laid in a row on a table. How many different arrangements are possible if no 2 black cards are allowed to be adjacent to each other? So we can think about just like the red cards first. So the requirement is based around the black cards, so let's lay out the red cards first. So we have the 7 red cards. Let's just denote them with like circles. So the 7 red cards. Okay, so we have 7 red cards here. And we have to place black cards in between the red cards, or besides the red cards, so that no 2 black cards are allowed to be adjacent to each other. So if we think of these like spaces, right? If we think of these as spaces, these are the spaces that black cards can go into. And for no 2 black cards to be adjacent, only one card can fit in one space. So we end up with just choosing 3 spaces out of the 8 spaces we have here. So you end up with A choose 3, and that's just equal to 56. And so that will be our answer, 56. Yeah, we take 3 black cards and we put them in these spaces. Like this. I think you get the idea? Okay.
Yeah. I don't really have anything to say there. I think that's probably like the simplest way you can do it. So yeah, okay. Now we're going to move on to the team problems, and we're going to start with number 1. How many positive integers between 1 and 60 inclusive are divisible by 5, 4, or 5, but not 6? So we can start by doing this problem by first just finding the integers that are divisible by 4 or 5, and then we can take out the integers of those that are divisible by 6 afterwards. So first we're going to figure out how many integers we have that are divisible by 4 or 5. So we want to think about the integers that are divisible by 4 and the integers that are divisible by 5, right? So the integers that are divisible by 4, there are going to be 60 divided by 4 or 15 of them, right? Like one way you can think about that is that we're going to start with 1 times 4, which is 4, right? And then we're going to have 2 times 4, 3 times 4. And this is going to go all the way up to 15 times 4, which is 60, right? And then you can see here that we have 15 numbers that are divisible by 4. And then, so same thing goes with 5. So it's going to be 60 divided by 5 is equal to 12. So we're going to have 12 factors between 1 and 60, or 12 integers between 1 and 60 that are divisible by 5. But we want to find how many integers are divisible by 4 or 5. And that's different from just 15 plus 12, right? Because if we add 15 plus 12, there's some integers that are going to be divisible by 4 and divisible by 5, right? Like 20. And those numbers will be counted once when we're counting the numbers that are divisible by 4, and once when we're counting the numbers that are divisible by 5. And so then when we add 15 and 12, we're considering that number twice. And so we're going to be over counting that number if we just add 15 plus 12. So what we could do is we could add 15 plus 12, but then subtract the overcounting that we did to those numbers, right? So we're going to overcount the numbers that are divisible by 4 and 5 by 1, right? Because we're counting them twice, but we only want to count them once. So then we can figure out how many numbers between 1 and 60 are divisible by 4 and 5, and then we subtract that from 15 plus 12. So numbers that are divisible by 4 and 5 is just going to be divisible by 20, and there are 3 numbers that are divisible by 20. So then we're going to have 15 plus 12 minus 3, and that's going to be equal to 24. So this is saying we have 24 numbers between 1 and 60 that are divisible by 4 and 5. But now we have to add the but not 6 parts. So we want to subtract any integers that are divisible by 4 or 5, but also are divisible by 6, right? So what we could do here is we could just look at the multiples of 6. And we want to count the multiples of 6 that are also divisible by 4 or 5, right? And so like you can think of like listing out the multiples of 6. So like 1 times 6, 2 times 6, 3 times 6, and then I guess I can just list them all out. 4 times 6, 5 times 6, 6 times 6, 7 times 6, 8 times 6, 9 times 6, and then 10 times 6. So we have 10 multiples of 6, and we want to count how many of these are divisible by 4 or 5, and then we want to subtract that from our total. And so we can first look for divisible by 4. So 6 only has one factor 2. So for multiple of 6 to be divisible by 4, it's going to need another factor 2. So that means the other number that's being multiplied by 6, it needs to be even. So then we can count all of these even multiples of 6, and all of them are going to be divisible by 4, right? So we're going to count all of those because they're divisible by 4 or 5. And now we need to count which ones are divisible by 5. And 6 doesn't have any factors of 5, so it's just going to be which of these numbers have a factor of 5, which is going to be 5 to 10. We're going to count 10. So then you can see that there are 6 of these numbers. So we're going to take 24 minus 6, and that's going to be equal to 18. And we're on number 1 target. Yeah, that is the correct answer, 18. Anything you want to say there, Bill?
No, I think this is pretty like straightforward, I think.
Yeah.
Okay.
Okay. Next question, number 2. Miss Forsyth gave the same algebra test to her 3 classes. The first class averaged 80%, the second class averaged 85%, and the third 89%. Together, the first 2 classes averaged 83%, and the second and third classes together averaged 87%. What was the average for all 3 classes combined? Express your answer to the nearest hundred. So for this problem, we can start by labeling the number of students in each class. So we can say x is the number of students in the first class, y is the number of students in the second class, and z is the number of students in the third class. So we want to look at, so it says together the first 2 classes averaged 83%. So we can say an equation for that. So we can say that the average of the first class, zero point 0.8, times the number of the students in the first class plus um, the average of the second class times the number of students in the second class over the number of students in the first class plus the number of students in the second class, that's going to be equal to the new average, which is 0.83. So how I got this was, like, we're basically doing a weighted average of the two class averages, right? And then so same thing goes for the other thing with the second and third classes. So we can say 0.85y plus 0.89z over x, or sorry, over y plus z is going to be equal to 0.87. And then you can see here that we only have two equations, but we have three variables. And um, in and so actually here you don't care about so like in this problem you can scale up or scale down all of the number of students in each of the classes by like any amount. So all you're looking for in this problem is going to be a ratio of all the of of the students of each in each class, a ratio of each of the students in each class. So then if you're looking for a ratio, you're only going to need two equations for three variables. And so like if you're looking for a ratio, an easy way to solve this is just to plug in a random number for any of these variables and then solve for the other variables, and then you look at your numbers and then you just put that into your ratio. So to make this easy, we can just set like x equal to 1, and then like this equation would be 0.8 plus 0.85y, and then this would just be 1. And then we also have a calculator for team, so then we can just also put this into a system of equations. Okay, yeah. So if you put these equations in, then you'll get so we set x equal to 1, so you'll get y is equal to 1.5, and z is equal to 1.5 as well. So then you can see that the ratio of x, y to z is just going to be 1 to 1.5 to 1.5. And if you set any other variable as anything, you'll always get the same ratio. And then, so then we're looking for the average of all three classes combined. So then that's just going to be a weighted average of all of their averages. So that's going to be 0.8 times 0.8 times x plus 0.85 y plus 0.89 z over x plus y plus z. And then so again, for this, like all you need is a ratio of x, y, and z, right? Because if you scale x, y, and z up or down a factor, this total average is still going to be the same, right? So then I can just substitute values for x, y, and z however I want, as long as it's still in my 1 to 1.5 to 1.5 ratio. And then to do that easily, I can just put it directly as x equals 1, y equals 1.5, and z equals 1.5. And like, even though you can't like actually have like you know, fractions of students, like it doesn't matter in this case because you know all we care about is the ratio. So then if you plug that in, you'll get that you'll get that this total average is equal to 0.8525, and then it wants you to express your answer to the nearest hundredth and as a percent, right? So then your answer is going to be 85.25, and that is the correct answer. Okay, so anything you want to say for that one, Bill?
Uh, Not really. It's just, yeah, I think it's also just pretty straightforward of just finding the proportions. Okay.
Okay. Okay, so next question, number 3. The mean, median, unique mode, and range of a set of 8 positive integers are each 10. What is the largest positive integer that could be part of a set? Okay, so you want to do this problem, Bill?
Yeah, sure. Okay. So we can start out with let's just start out with 7 tenths. So 10, 10, 10, 10, 10, 10, and then 20. So this meets the requirement of having the median and the unique mode and range at 10, right? But we need to get the mean down. So to get the mean down, we will need to decrease these numbers. So to decrease 10. So first of all, we can just try. We also still need to keep these. We also still need to keep 10, the unique mode. But also we want to make the numbers we decrease. We want to decrease them as little as possible to keep the highest number as high as possible, right? So we can just do 9 first. So if we decrease 3 of them by 9, that leaves 10 of them by 4. 4 tenths, and then this will be 19. So the top here, this one gives you what? It gives you 90. And we need to get it to 80. We need to get the sum. We need to get the sum to 80 for the mean to be 10. So this is 90, but so here we decrease everything by 4. We decrease 4 numbers by 1. So this will be 86. So this is not enough. So we do it again, but this time with like 8. So, 8 and then dot 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 18. This will be 82. So still not low enough. But if we keep going, we can do, sorry, my bad. We can do 7th dot 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 17. And now we get to 78, which is low enough, which is lower than 80. So to get to 80, we can just change 2 of these to 8 and then leave the rest as 10. And that will be your answer. And so our highest number will be 17. So the largest possible integer is 17.
Yeah, so whenever you have problems like, I don't know, like mean, median, mode, range problems, and it like gives you like what they are. Like often a good idea is to try to think of a sequence that like satisfies like most of the conditions, and then like try to manipulate the sequence to like satisfy like the last condition. Yeah. Okay, so we can move on to the next problem. Number 4, participation in the local soccer league is 10% higher this year than it was last year. Also, from last year to this year, the number of males increased by 5% and the number of females increased by 20%. There were 20 males participating in the league last year. What fraction of the league's participants is female this year? Okay, so we have some males and females doing soccer like last year, and then they're increasing by some percentages this year. So what we can start by doing is we can start by finding the proportion of males and females last year. And we can do that because like it tells us how much males increased by from last year to this year and how much females increased by, but also how much the total league participants increased by. Well, that's assuming that males and females incorporate the whole population, I guess. But I guess we're just assuming that. Okay, so we can set like m the variables m and f to be the number of males and females last year. So participation in the local soccer league is 10% higher this year than it was last year. So we're gonna have a total of 1.1 times n plus f, that number of total participants this year, right? We can set that equal to the increase of males and increase of females individually, right? Because we're assuming that they comprise of the whole soccer league population. And we're told that males increase by 0.5%, so we're going to multiply m by 1.05, 1.05 times m, and then we're going to multiply f by 1.20. Okay, so then we can just distribute 1.1, and then we can just combine like variables to solve for a ratio. So I'll subtract 1.1. So I'll put males on this side. So we're gonna have 0.05 males is equal to 0.1 times females. So this is males and females last year. And then so if we divide 0.1 by 0.05, we get 2. So then this is saying we had double the number of males and females last year, right? And then it tells us that there were 20 males participating in the league last year. So that's just telling us that m is equal to 20. So if there are twice the number of males and females, then we can say that the number of females last year was 10. Okay, now we want to find what fraction of the league's participants is female this year. Express your answer as a common fraction. So first we can find the number of females that are in the league this year, and we're told that it increases by 20%, right? So that's just going to be 1.20 times f, which we found was 10. And 1.2 is just going to be 6/5, which is just 12/10. So this is going to be equal to 12. So you have 12 females this year, but we want to find the fraction of females this year to the total number of league participants, right? And we can find that by just doing 1.1 times n plus f, right? Because the total number of participants last year to this year increased by 10%, right? And then we know what m and f both are. So then this is just going to be equal to 1.1 times 30, the sum of 20 and 10. And then this is just going to be equal to 33. So then our fraction is just going to be 12 over, 12 over 33. And we can take out a 3 from top to bottom. So that's going to be equal to 4 over 11. And then that is the correct answer. So yeah, our answer is 4 over 11. Good. Anything you want to say for that one, Bill?
Uh, so you you didn't necessarily have to like do it via algebra. Like this is really low numbers, like really small numbers. 20, 21, like that's pretty small of a number. So you could definitely get away with just like trying out some numbers. And also like for the females to increase by 20%, like there has to be a multiple of 5 of females. So like there's only that many numbers to try, and it's 10, right? So you don't have to try that many if you like. So the algebra isn't like definitely isn't like the only way to do this.
Yeah. Yeah, because the numbers are so small and you know that they're going to be integers, you can just test it. But I mean, I would say like the algebra here isn't that bad either. I mean, I don't know. I feel like I showed a lot of work, but like if you're doing it quickly, I don't think it's that bad. Okay. We can move on to the next problem. For all real numbers R and S, define the mathematical operation um, hashtag. I'll call that hashtag, such that the following conditions apply. R hashtag 0 equals R hashtag S equals S hashtag R, and R plus 1 hashtag S equals R hashtag S plus S plus 1. And then you want to find what is the value of 11 hashtag 5. Okay, so for these type of problems, so like, random operation problems, you wanna just like play with the operation a little bit. Um, and you want to play with it a little bit, and then maybe you can find like properties or something where you can like actually solve it and stuff, right? So, we can look at each of these with 11 hashtag 5. So like we can see that the first condition R hashtag 0 equals R, that's not going to be directly helpful to 11 hashtag 5, obviously. And same thing with R hashtag S equals S hashtag R. That's not going to like do anything for 11 hashtag 5 like immediately, right? So then, what we should kind of play around with 11 hashtag 5 first is the last condition that they give us. So R plus 1 hashtag S equals R hashtag S plus S plus 1. So, we're just testing these right now, so we can just we can we can just like try this directly with 11 hashtag 5. So, we can set R equal to 10. So 10 plus 1 hashtag, um, you can say S is 5. So that this way, we still have the 11 hashtag 5. We're saying 11 hashtag 5 equals 10 plus 1 hashtag 5. And then we can apply the third condition that they give us, right? So R is going to be 10. So 10, it's saying that 11 hashtag 5 is equal to 10 hashtag 5 plus 5 plus 1. And then you can see that like basically what we did here was we did was decrease the first number on our hashtag, and then we added the other number on a hashtag plus 1, right? So then what we can do is, like we can put 10 hashtag 5 into 9 hashtag 5. We're decreasing the left number by 1, but then we're adding the right number and 1. But also we still have this right number and 1, so we're still going to add this number and 1, right? And then what we could do here is we can just go ahead and put this 9 hashtag 5 all the way down to 0 hashtag 5, right? And this would be really good because, you know, 0 hashtag 5 from the second condition, we could just put that as 5 hashtag 0. And then from the first condition, anything hashtag 0 is just equal to that first number, right? So then we can get rid of all of our hashtag signs in this, and then we can just have numbers, and then we can just find the direct value, right? So then we could just do that. And then, but we need to find like how many plus 5 plus 1s we have. But that's pretty easy. You can just see that like every time you decrease it by 1, you have plus 5 plus 1, right? Which is just plus 6. And we're decreasing 11 all the way to 0, right? So we're going to decrease it by 11 times. So that means we're going to have plus 6 times 11 over here. And then, oops, okay, so 11 hashtag 5 is equal to 0 hashtag 5 plus 6 times 11. So like I said before, we can flip the 5 hashtag 0 around, and then now we can apply the first condition. So 5 hashtag 0 is just equal to 5. We get rid of the hashtag. And now we just have a direct value. So then it's just going to be 5 plus 66. And that's going to be equal to 71. And then that is the correct answer. And our answer is 71. Okay, anything you want to say for that one, Bill?
Yeah, it's just kind of recursion, and it's just kind of like it's just figuring out like what's happening every time you recurse it, and like how long this recursion goes on for. So with recursion like this, sometimes it might be good to like do the first few recursions just so it makes a bit more sense to you. And yeah.
Yeah. Yeah, I would just say like generally for these operation kind of problems, you just kind of want to play with the conditions that you're given. Okay, so you can move on to the next problem, number 6. A right cylindrical oil tank is 15 feet tall, and its circular bases have diameters of 4 feet each. When the tank is lying flat on its side, not on one of the circular ends, the oil inside is 3 feet deep. 3 feet deep. How deep in feet would the oil have been if the tank had been standing upright on one of its bases? Express your answer as a decimal to the nearest 10. Okay, do you want to do this one, Bill?
Let's just look at the So let's just think about what the tank is looking like right now. So it has a circle like this, and it kind of, and then that's a good circle. So this diameter 2 feet, so diameter 4 feet, so each one is 2. And then the water right now is at 3 feet, so like somewhere about there. So this is 1, this is 1. And we connect this, so it's like this. Oh, so it looks somewhat like this. It's not a perfect graph, but um, so we kind of want to find the proportion of the oil to the like volume of the tank, how much oil is in the tank. So we can just think about this in terms of this circle and the triangle here. So this is where the oil is. So because this is one half, this is 2, right? And this is 1, so we know that this angle is 60 degrees. If this angle is 60, and then this whole thing will be 120, so this is 240 degrees. So that's 2/3 of the area of the entire circle. So 2/3 times 4 pi. That's the circle right here. Plus, now we have to do the triangle, which is this is 1, and because it's a 30, 60, 90, because it's 60, 30, and that's 90, this would be square root of 3. So we would have, so the area of the triangle will be square root of 3, because 1 times 2 is square root of 3. So that's the area of the oil. Now we put this over the area of the entire circle itself, which will be 4 pi. And some quick math. And then actually we can do this. We can just do this. So this is the proportion of the oil to the entire tank. So now we multiply this by how tall the oil is, which is 15 feet. And so if we put this in the calculator, we get around 12.1 feet. It says to round to the nearest tenth. And yeah, anything about that?
No, I think that's the no, no, like pretty good way to do it. So yeah. Okay, we can move on to the next problem. Number 7, boxes of heights 8 inches, 9 inches, and 10 inches are available. There is an infinite supply of boxes in each of the three sizes. Every every possible stack of 6 boxes with a unique stacking sequence is to be made once, such that each stack is 1 box wide and 1 box deep. If John is to select one of these stacks at random, what is the probability his stack is exactly 54 inches tall? Express your answer as a common fraction. Okay, so we have boxes, and we're stacking the boxes. And when it's saying such that each stack is 1 box wide and 1 box deep, that's just saying like we're just stacking the boxes like directly on top of each other, and we just have um, you know we're not stacking like the boxes like length or width wise. We're only stacking them on top of each other. So we're stacking 6 boxes, and the 6 boxes can be of any height, 8, 9, or 10. And we want to find the probability that the stack is exactly 54 inches tall. And every possible stack of 6 boxes with a unique stacking sequence is to be made once. Okay, so how can we like simplify this problem? Well, if we have 6 boxes stacked on top of each other, their total height is just going to be like, you know, some combination of 8, 9, and 10 all added together, right? Like 8 plus 9 plus 10 plus 8 plus 9 plus 10 or something like that, right? Oops. Okay. So, so when it says we're making like a unique stacking sequence once, like every possible stack of 6 boxes with a unique stacking sequence is to be made once. Like we're doing like all of the possible permutations of um, 8, 9, and 10 that are possible, right? And so, we can first think about like how many total stacking sequences can we make, because we're going to need that for the probability at the end. Um, so that's pretty easy. It's just going to be so like you can think of like we can think of like we have like six positions, and each position we could choose 8, 9, or 10, right? And then like our condition is that all of these numbers in our positions is going to add up to 54. But first we're going to find how many total sequences can we make with this. Well, we can choose 8, 9, or 10 in each of the positions, and we don't care about like um, anything else really. So then it's just going to be a choice of 3 for each of the positions, and we're just going to multiply all these threes together, right? And since we have 6 positions, then the total number of sequences you can make is just going to be 3 to the 6. Okay, so now we want to figure out how many actual stacks can we have that stack to 54 inches tall. So that's just going to be like how many positions like this can we have where the sum of all the numbers is going to be equal to 54. Well, you can start by thinking of like um, one one way you can stack the boxes, and you can see that one way you can stack the boxes is to have 6 9-inch boxes, right? Because 9 times 6 is 54, right? So one way we can have them sent to 54 is if we have 6 9-inch, or I'll just say like six nines. Okay, so let's just think about combinations now, and then we can put them into permutations later. So what's another way we can do this? Well, another way we can do this would have to be like incorporating 8-inch and 10-inch boxes, right? And if we were to substitute an 8-inch box for a 9-inch box, we would also have to substitute another 9-inch box for a 10-inch box, right? Because then the average of the 8 and 10 would still stay the same to be 9, right? So so another way we can do it is to have 4 nines and two, or sorry, like one 8 and one 10. 1 8 and one 10. Okay. And then so we can keep on substituting 8 and 10s for the nines. So we can have 2 9s, 2 8s, 2 10s. And we can also have 0 9s, 4 8s, and, or sorry, not 4 8s, 3 8s, and 3 10s. Okay, and those are all the possible combinations we can have to have our boxes stacked to 54 inches tall. Okay, so now we want to think of how many uh, how many permutations can each of these combinations have, right? Because in this case, we're counting permutations and not combinations. But so for 6 9s, it's just going to be 1, right? Since you can't order 6 9s in any different way. But for 4 9s, 1 8, and 1 10, so first, what we can do is we can think about so we have 6 positions. Uh, we can think about the choosing the positions that the 8 and the 10 go. So like we do 6 choose 2. We're choosing 2 positions out of the 6 positions to put the 8 and 10 into. And then the rest of the positions are just filled with 9s, right? But you can't just have that 6 choose 2 on its own because um, then in that case your 8 and 10 is still like undecided in those 2 positions, like where to go, right? But for that, then you can just do 2 choose 1, right? Because like so like so so now so like okay, so we had 6 positions. We chose 2 positions, and those 2 positions are where the 8 and 10 will go, but we don't know like if 8 or 10 is going to be on the leftmost one or the rightmost one, right? But we do know that all the other positions are going to be filled with 9. Okay, so then we have to decide where the 8 and 10 will go in those 2 positions that we chose out of the 6, right? And for that, do two we can do 2 choose 1, right? Because we have 2 positions and we're choosing like one number to go in. Like we can choose where the 8 will go, and then the other position will just be where the 10 will go, right? For the next one, 2 9s, 2 8s, 2 10s, we're kind of just we can just kind of do the same thing. So out of the starting 6 positions, we can choose 4 positions for the 8 and 10s to go. And then out of those 4 positions, we can then choose like where the 8s will go, and then the 10s will be filled in, right? So then we could do 6 choose 4 times 4 choose 2. And then 0 9s, 3 8s, 3 10s. Well, if we're continuing it in the same fashion, we can do 6 choose 6 times 6 choose 3. Okay, then we want to figure out what the actual values of these are. So 6 choose 2 is going to be just 6 times 5 over 2. So 6 choose 2 is equal to 6 times 5 over 2, which is equal to 15. And so then here I'll put the values of these all in this column. Actually, that looks pretty bad. I don't know. I'll just say like this is 1. Okay, and then for this one, this is going to be 15 times 2 choose 1, which is 2. So this one is going to be equal to 30. So this one's 30. Okay, and then 6 choose 4 is equal to 6 choose 2, because 6 minus 2 is 4. So then we want to figure out what 4 choose 2 is. Well, 4 choose 2 is just going to be 4 times 3 over 2, and that's going to be 6. So then this one is going to be 15 times 6, which is equal to 90. And then 6 choose 6 is just 1, and then 6 choose 3 is just going to be 6 times 5 times 4 over 3 factorial, which is 6. So then 6 is canceled, so then this is equal to 20. So then this is just 20. So now in this column, 1, 30, 90, 20, we can add all of them together. So then we have a total of 141 cases. Okay, so now our probability is going to be 1 to 41 over a total number of cases, which is 3 to the 6. And then you can put this into your calculator to for it to automatically simplify, and then you get that this is equal to 47 over 243, right? Like you want to be careful of simplifying this, right? Because like 141 is divisible by 3. Okay, so then the correct answer is 47 over 243. So yeah, that is our answer. Okay, anything you want to say there, Bo?
Right, on this question, just be careful. It's a question where you should be careful reading the question because you need to notice that it says each unique stacking sequence, so and not like just how many different combination of boxes can be. So
Yeah, yeah, yeah. For problems like this, you want to be careful always with like combinations and
yeah, like when you're
permutations and
doing a
that kind of
problem,
stuff.
you should always read the problem carefully. Make sure you read the problem carefully.
Yeah.
Okay.
Okay. It's 4:33, so we can go ahead and end there.
Mhm.
Um, thank you for coming to our meeting, and we'll see you next week. Bye.